Greetings to all the viewers. Now, let me continue with the session called azo-coupling reaction. It is the part of named organic reactions. The concept of what we are going to discuss is retrieved from the textbook called the Textbook of Organic Named Reactions. This is written by Dr. Kavita Kottireddy Kota. So, now let me continue with azo-coupling reaction. Not only this, the series of sessions, whatever we conducted earlier and whatever the conceptual or bit point of view, so all are available at the channel called World of Competitive Chemistry. Let me go with the azo-coupling reaction. Azo-coupling reaction is an electrophilic aromatic substitution reaction where diazonium salt react with activated aromatic compounds like phenols and aromatic amines to form azo-nitrogen-nitrogen double bond compound often used in azo dyes. This is the most important application in dyes manufacturing, in coloring agents manufacturing, right? Let me provide the reaction with this diazotization azo-coupling reaction. Benzene diazonium chloride is one of the reactant to be treated with activated compound, either phenol or else aniline are supposed to be treated. Whenever these two compounds are treated, the para position is activated with respect to this phenol or aniline, so that here para position with the electron rich nature is able to bind up with the nitrogen, so that bonded electrons are moving back towards the nitrogen. You can notice the diazo. So diazo bond formation is possible. Later on, it will retain its aromaticity, and eventually you can notice benzene diazonium chloride. Sorry, diazobenzene formation is possible. As a coupling reaction is accomplished, a coupled product is noticed over there. So here, in order to understand that activated compound, either phenol or aniline, starting with this benzene diazonium chloride, first of all, we need to synthesize this compound, right? This compound not directly available some cases. In that case, you need to go for its manufacturing. It's a process of synthesis. Let me start with aniline. Aniline is a precursor for the manufacturing of benzene diazonium chloride. So aniline to be treated with sodium nitrite and hydrochloric acid. Sodium nitrite, hydrochloric acid together able to generate HNO2 called nitrous acid. Nitrous acid not available anywhere in the market. You can't purchase. Rather, it to be synthesized in situ. Within the reaction only, you need to synthesize that one, being it is a short-lived, being it is unstable, so that immediately oxidation through the air converted into nitric acid. That's the reason why directly by mixing sodium nitrate and HCl, immediately you can generate the molecule. Immediately it will go for the reaction with this amino functionality, and the temperature should be maintained at 0 to 5. It is of cryogenic condition more preferable for the accomplishment of this benzene diazonium salt formation. Later on, benzene diazonium chloride to be reacted. That is called as a coupling reaction, either by aniline or phenol. Either of the compound, you can treat both are activated compounds only. And the para position suitable for the coupling with diazonium salt, so that in between the compound generation is this is called diphenyl azo compound. This is also called diphenyl azo compound. As a coupled product formation is possible, the step number 1 is designated as diazotization, and step number 2 is called as a coupling process. This is the way you can accomplish the product formation, starting with benzene diazonium chloride. Either aniline or phenol are able to generate the same as a coupled compounds. In order to accomplish this reaction, here copper cobalt oxide catalyst to be achieved, to be added. Catalyst will enhance the rate of the reaction, so that you can achieve the product in the short span of time with high quality and purity. If you are taking 2 moles of aniline compound with the methyl substitution, simply said to be paratolidine. And paratolidine, if added, that able to converted first into benzene diazonium salt, subsequent treated with aniline. Subsequently, it is converted into a compound called diazo. Diazo compound formation is possible. This is the way kind of application is noticed for the final product formation. In order to understand the mechanism for the reaction, let me take a starting material primary amine. A primary amine to be treated with HNO2. This HNO2 generated by the mixture of NaNO2 and HCl, right? That HNO2 nitrous acid, we can designate nitrous acid able to convert amine into benzene diazonium chloride. Whatever benzene diazonium chloride generated able to react with aromatic compound with activating functional groups like either NH2 or OH, benzene diazonium diazo coupling product formation is possible. So that diazonium salt formation is the step number 1, coupling reaction is the step number 2. So that is simply provided over there when we are taking diazonium, benzene diazonium chloride, and treated with this phenol molecule. What phenol is doing, being it is activating functional group, lone pair electrons are moving towards the benzene ring. Whenever electrons released into the ring, ring will get activated. Whenever ring activated, delocalization of electrons taking place in the simultaneous manner, and the para position having the high electron density and give the electrons to the nitrogen with the new bond formation between the nitrogen and carbon atom. Simultaneously, existing pi bond is moving towards the deficient quaternary nitrogen atom. This is the way a new aza linkage noticed in between, and here there is a oxonium quinanoid form originated. Now let me go for the protonation. So in the presence of chloride, deprotonation taking place from this para position. Whenever deprotonation taking place, the bonded electrons are moving inside the ring system, so that this pi bond is moving over there, and this pi bond back polarized onto the oxygen, and here the deprotonation that able to generate the benzonoid form. This is the way as a compound formation is possible, right? You can notice all these compounds which are said to be dyes, coloring agents, which are manufactured by this as a coupling reaction. So many textile and even materials like plastics, different colors, you can notice all these are taken from, all these pigments are taken from as a coupling reaction only. So here's a few examples pertaining to as a coupling reaction. You can notice when aniline treated with NaNO2 HCl diazonium salt, the diazonium salt treated with phenol giving rise to aza compound, and even diazonium salt treated with aniline giving rise to again aza compound with the substitution of NH2. Let me extend the reaction to various kind of coupling product formation, so that aniline, by default aniline will be the starting material anyway. You can achieve this benzene diazonium chloride. Instead of phenol, I'm taking beta naphthalate, sorry, alpha naphthalate. So one of the benzene ring extra, that means a fused ring system was taken. Alpha naphthol is supposed to be treated with this one. Again, it is being OH is a ring activating one. That's the reason why para position is going for the coupling reaction with aza functionality. You can notice the diazo coupling over there. So that it is the another extension of the reaction process. Again, benzene diazonium chloride able to bind up with the aniline, giving rise to another provision. This is not preferable for this aza coupling. Rather, diazonium compound formation instead of this triazo compound azide may not be generated at a normal condition. Rather, if pH exceeded 7, that means the basified conditions, if provided the reaction is somewhat beyond the limits, right? So I'm taking benzene diazonium salt once again, and it is treated with this kind of pyrrolidine, saturated, completely saturated pyrrole was taken over there, so that here again azide formation taking place, 3 nitrogens on the same line, right? So this is a kind of extending or exploring the research based on this diazonium salts. I'm taking thiophenol. Again, it is the kind of heterocyclic ring system only. And here we are having diazonium salt. Benzene diazonium salt was taken. If this is the compound is treated with this, so what it will do? The position alpha with respect to sulfur is suitable for this coupling reaction. You can notice the diazo coupling over there. So the remaining functionalities may not be altered. And here you can notice the kind of diazo linkage. And the similar manner, this is of most important application containing reaction. Examination point of view, it will be important. If you are taking the What it will be? Imidazole. 1,3-nitrogen containing imidazole was taken upon the nitrogen. First nitrogen, you can notice the kind of aniline. This aniline is the focus of our study, not this imidazole. Imidazole, in general, you can notice imidazole is the functionality side chain over there, because we require amine functionality for this diazotization, right? So that whenever this NH2 is treated with the sodium nitrate and HCl, diazotization at a pH 5 to 6, if operated, instead of diazonium salt formation, rather it will go for the ring cyclization reaction. There is a formation of ring cyclization reaction in between, and you can notice this reaction. This is given in the CSIR NEET question as well, right? Here it is the kind of another molecule that is carbazole derivative. So dibenzofused pyrrole is said to be carbazole. It is supposed to be treated with benzene diazonium chloride. Being it is the kind of coupling agent and it is activated compound, obviously, this position is more susceptible for this coupling reaction. You can notice as a coupling over there. More the conjugation and more will be the complexity of that color, and more will be the intensity of the color. Intensified coloring compounds will be originated as we are increasing the conjugation within the molecule. This is the way much more exploration regarding these what it will be. Azo coupling reaction is noticed. I'm taking beta-naphthol. Beta-naphthol is treated with alkaline condition that able to pull up the hydrogen so that beta-naphthoxide formation is possible. That will participate in the keto-enol tautomerism so that simply you can achieve the double bond and O minus. Again, it will go for the ring as a coupling reaction with benzene diazonium chloride. Whenever benzene diazonium chloride is added here, the electron reach alpha carbon atom is noticed that able to bind up with this nitrogen, and subsequent pi bond is moving toward this side. So that the new bond located over there, this is called as a coupling reaction with respect to alpha position is accomplished. That is finally uh, alpha position as a coupling reaction in affecting that beta position. This is the red color dye which is established in a dyeing agent. So here it is designated as phenyl azabetanaphthal. This is the way product formation is accomplished. I'm taking that para position blocked in order to understand whether it is possible or feasible to continue the reaction in order to achieve the product. Is there any provision? If para position is blocked, what it will do? So that's the reason why benzene diazonium salt is treated with this paramethyl phenol. Phenol para position, more obviously it will go for the coupling. If the position para is blocked, obviously the second thought is going toward the other position so that ortho coupling product is feasible. Hence, the reaction is feasible even with the ortho if para position is not available for the coupling reaction, right? What factors are operated in order to accomplish that as a coupling reaction? Factors influencing as a coupling. Substrate structure. Electron donating groups are activating one so that the reactivity will be uplifted by electron donating substitutions on the aromatic ring system. pH. Alkaline conditions are favorable. pH must be in the range of 8 to 10. Alkaline conditions are feasible for that pulling a proton from that system so that more nucleophilic nature arised, which is suitable for the coupling reaction. Temperature. Oftenly, cryogenic conditions are sufficient for the completion of the reaction at 0 to 5 degrees centigrade. The reaction proceeds smoothly. So that temperature should be lower. And the order of reactivity for the coupling reaction will be NH2 more favorable, later on hydroxyl and later on secondary amine, later on alkoxy. And you can go with the methyl and hydrogen, and the least is given for halide. This is the way reactivity nucleophiles are provided. Accordingly, coupling product formation is possible. Schema formation is provided for this aniline to be taken. Aryl oxygen is supposed to be added on oxygen catalyst, and in the presence of this catalytic condition, this aniline go for this cation radical. Cation radical is added with any other aniline. What it will do? There is a formation of diazo compound. The diazo compound is altered further, and there is a diazo Aromatic diazo compound formation is possible. This is another plausible mechanism by copper catalyzed conditions, right? So this is another provision. But in simple manner, whenever aniline treated with sodium nitrite and concentrated HCl at to 0 to 5 degrees centigrade, where HNO2 generated within the reaction vessel, and that able to bind up with this NH2, giving rise to diazonium chloride salt. Diazonium chloride either reacted with aniline or phenol. Accordingly, the product formation is possible. Applications. We are going to conclude the session by introducing their applications. Applications are most important in the perspective of its importance and significance. Iso dye. Primary application isocoupling reaction is iso dyes. They are coloring matter in the textile industry like fabrics, like clothing agents, and even in the printers. So cartridge, whatever used to give the ink pillars, ink printing is also provided with these azo dyes only. Even food colorants also made by these azo dyes in electrical chemistry. Azo compounds used as a pH indicator. They able to change the color by changing the pH. That's why pH indication is indicated by this analytical molecules in the presence of azo dyes. So that analytical tools they are in order to diagnose that pH of the medium, either acidic, basic, or neutral. That nature you can analyze, right? If you are taking methyl orange, it is the kind of dye only. So that orange color one, orange color you can notice, and para red is also a kind of as a compound where color change. That's the reason why they are essential indicators in the volumetric analysis. Even in the biochemistry, is a compounds, some biochemical assays and straining agents they use to color the substances, coloring matter they are. This is the reason why even in the biochemistry you can apply them. Textiles and inkjets painting biochemical markers they utilized. Example for the diazotization reaction is provided. If you want to take aniline, aniline with the sulfonate moiety at the position number 4, para position substituted by sulfate moiety, supposed to be treated with diazotizing agent NaNO2 and HCl, so that benzene diazonium chloride originated. So, and this whatever sulfonate moiety is there, that will not participate in the reaction. Rather, the wherever diazonium chloride is there, that part is active toward this coupling reaction, so that you can achieve the as a coupling over there, as a coupling over there. This is the reason why the kind of coupling reactions give the extension of the conjugation, and they are working like chromophores, coloring agents. They give the color to the paints, color to the textiles, color to the pharmaceuticals, color to the plastic. So many coloring agents they are utilized for. We are going to conclude the session. As a coupling is a valuable versatile reaction in the synthesis of azo compounds, which are characterized by the nitrogen-nitrogen bond as a linkage is a characteristic feature for this kind of coupling reaction. These compounds are widely used in industries like vibrant colors and stability is indicated by these. And straightforward reactions are accomplished by this one, and mild conditions are sufficient. Widely used in organic and industrial chemistry as well. This is the way we successfully accomplish the entire azo coupling reaction, and they simply coloring matter. Right. In the next session, we will go with the amoxidation. Right. So hopefully the session is very informative for your preparation and you enjoyed the session, I hope. And if you want to know about more chemistry, you can go through the channel World of Competitive Chemistry. Thank you very much for your patience.